Hi, in these videos, we are going to talk about some Docker container technology. I will use this PDF from Beijing Qianyi Tan. Uh, this class is very famous. If you want to go to the official course, you can Google search Qianyi Tan and register in their new class. I think this is very valuable and can help you to learn more technology. So in this class, we'll cover about here different items, right? First is talk about the Docker introduction, why we need a Docker, and also the installation and different components of Docker. Also cover some different commands, right? Docker has the image, has container, also other commands. We'll cover all of them. Also talk about the Docker data, especially for some data you want to permanently to save it. So here this special item will cover that part. Also Dockerfile. Docker usually not built by manually. Instead, you use Dockerfile to build from a code, so you can do some version control of this Dockerfile. Also talk about the Docker network. How can you expose your Docker to the kernel? How can you let two containers to talk to each other? This will in the Dockerfile, Docker network. Also talk about the Docker component, because usually Docker just in the micro services, right? So each application should compose of multiple services. So Docker Compose just talk about how to quickly to run in multiple container, and then they can work together to provide services. Also talk about the DevOps for CI/CD. Also include Docker Swarm. Docker Swarm just mean usually in production, not only one host, physical host, maybe multiple, right? So how can you quickly use some tool to do orchestration containers in different hosts to provide redundancy and provide services? It's similar like the Kubernetes. Kubernetes is come from Google, and Docker Swarm come from Docker company itself. And then later we will talk about in production how to use Docker to monitor Cisco device. Also, there's some container example in the IOX. You know that currently when Cisco release some ISR or the other router, they all based on container technology already. So here just talk about how to run some container inside some Cisco router. So first part is talk about the Docker introduction, why we need a Docker and what exactly Docker it is. Here's the compare with the different generation. So basically I can think this should be generation 1, this is to be 2, this is 3. And yeah, long time ago, we only has this everything is running on single host, right? Like a one physical server. We go for some very powerful server, high CPU, high memory, but we run a lot of different applications on top of the hardware called bare metal solution, right? But the issue is here, right? One app crash, you will crash all of them. So it's not good. Also, it will be very complex, right? Different app, you may know that in modern app, there's a lot of the dependent library or dependent package there. Like in Python 3, you need to install a lot of different modules, right? But you cannot guarantee all the app has same requirement. Maybe you install the one special module for one app, your result in conflict with the other one, and result in the other one cannot work, right? So this is not good anymore, especially for some today modern application, which is so complicated. The other solution, now we go to the generation 2, which is running OS, right? So here is one OS, here's one OS, here's another OS. And each one is be isolated, right? So one crash, the other still okay, right? So this is good for the isolation, also can maximum to reuse the resources for the hardware part. And then now we go to the third generation with the container. So compared with the 2 and 3, you can see the big difference is this one. We don't have this one OS, right? This one and here is just directly don't have OS, don't have kernel. Because for OS itself, even it's lightweight, but still waste some resources. Later we have some PowerPoint to compare the performance between the VM and the container. So VM is kind of heavy weight, and while container is some lightweight, right? But solution is similar. They still keep the isolation. So one crash, the other still be okay, right? So this container benefit. Also, for sure, container has the other benefit. We'll talk about it later on. So here's talk about the limitation of the VM. What's the limitation of VM? First of all, like I say, when the single host, physical host, when you run the VM, even the VM didn't run any application, only has this OS, don't have any application, it still begin to result in CPU and memory cost, right? So based on the best practice, one single host, maybe it can run maybe maximum 10 VM. Even the VM didn't run any application on top of that, but let's see it, right? But container, maybe in the production, you can run hundreds or even thousands container because we don't have OS layer. You can save a lot of host resources layer. And the second of the VM is that usually VM, the lifetime should be very long, maybe over years. Every people can log in VM to installation, at some patch or something else. So everything is done by manually, and you cannot document all the behavior, right? So over time, each VM will become very unique, also hard to describe, right? No, especially for some VM, it's not built by you. And when the employee left the company, and maybe he didn't do any document, and also even he do document, cannot document everything he did for that VM. And someday the VM has some issue, and for you, which you take over this new project, it's very, very hard or impossible for you to rebuild exactly same VM, right? You may know what I mean if you have this appearance. So every VM will become irreplaceable. It cannot be replaced, right? Because it cannot be described. So that's the issue of the VM solution. That's why now I cannot say all of them already migrated from VM to the container, but at least it's a trend. More and more applications begin to migrate from VM to container. Because from application point of view, it doesn't matter, right? They have the same app, they can provide services. But from the operation point of view, container is much easier to manage compared with VM, especially we have some Kubernetes, which is a very good tool for the orchestration. So we talk about the VM limitation. Now we talk about something maybe it's a wrong understanding. Actually, it's also my wrong understanding. We just begin to learn this container. This is the first one, misunderstanding. right? So container is not another kind of the VM. A lot of people, when they just begin to learn the container, they always do some comparison between the container and VM. Say container can save some CPU, can save some memory, but actually the key thing is we should not compare with the VM with the container. We should compare the container with some services. This is more suitable, more proper comparison, right? So you can think about, here's the diagram here. You can think container is just kind of the services plus environment, right? Environment is very important. If you know some developer or do some program, you should know that. For example, in a Python, right? Use a Python 3 to build a website, but Python 3, your program cannot run it by yourself. At least you need Django, right? Also, you need some middleware. Also, you need some database, right? All of them is not in OS. It's not in OS. It's for example here, right? OS is a base, right? It's the same, it's a kernel. Then on top of your program is here, like a Python, right? But on top of that here, we can call it environment. Environment is in here. You provide all your necessary module. So for you, you only focus at the application, focus at the logical, right? An environment help you to handle everything else, like the missing module and library, and also some middleware, such like that. So we can think about the container is the real application plus the environment. So so here's the comparison. Each service has some running process, right? You have some process inside the services, but when the process is done, your service will gone, right? Later we can show you the real example. And container is also the same thing. You may know that for the process point of view, yes, some front end and back end. Right? Front end just means you can run in the standard in and standard out. But the back end just means it's just running back end, right? This is some special term in the Linux, right? But in each container, they need at least one front end process. If this front end process die, then whole container will be down, will be powered down, will be crashed. So this is my understanding. Compare this container and services. And container, you can see here, everything is within a square, so they are isolated to each other, right? So one crash, the other should be still survive. So that's why now currently, especially for Cisco, the router, when they begin to provide some special application, they are not provide the services, they provide a container, right? Because container is more secure, also already include the necessary environment layer. So here's an example of the services, right? If you log in, if you are a VIP student of the 前一堂 course, like I say, you can always to go to their website to register as a former student. You can get some lab environment. So in here, they have some platform, so you can run all the command in this PDM. So here is just an example show you that if you are Linux guy, you should know this command called systemctl. CTL is for the services control. You can start, stop, also to query the status, right? So inside this special program, they have a special timer, right? The timer will control after 20 seconds, then this process will crash, right? It should be easy, right? Like you can do some, sleep 20, then do some 1 divided by 0 to cause the whole process crash. Here just for some simulation to show you what's the behavior of the services when some process inside services has issue. So here just the system start this services, then you do some query, your system control status query yet, you can see everything is active, right? Then after 20 seconds, when this process crash, then you query the services, you can see it also fail, right? So that's why that behavior of the normal services issue come from day one when Linux was invented. Now we go to the container, right? Container you can see very similar, right? First of all, you go to the container Dockerfile folder. Later we will discuss about how to build your own Dockerfile. Here's the example, right? From where and how to build the Dockerfile layer. Then use the Docker build command, this dot, right? You can see this dot. The dot just means the Dockerfile here, right? So here T means tag, basically just give the name of this Docker image, right? Then you build this one, and so when it's finished, in your local repository, you should have an image. The name is called this calling stack, this name, right? Then later you can use the run command and give it a name. Later you may know that there's a difference between container and image, right? Here just build an image. Image is just similar like a class in some special language like Java or Python as a class. But when you build a real something instance, you are just build an object out of the class, right? So one class can result in multiple unlimited object. So here the same. One image can create multiple container, right? So here just give the container name, the name here. Then here's the image name. Let me this image result in this container, and -d that means this one container will run in back end, right? That means in the standard output you can continue to do other job while this container running in back end, right? If you didn't give it -d, then your whole standard input output will be occupied by this container. You cannot do anything until this container quit, right? So in this Dockerfile, in this app, we do the same thing. It can only last for about 20 seconds, then you crash, right? So when we begin to run this container, we use Docker PS. You will show you all the live, all the running container. So you can see this one still running there, right? And you can also use the Docker attach to the container to log into the container itself screen. Then you can see some output of container, right? So you can attach to it. This is in your own host. When you attach to it, you can log into the container itself OS. So it's different, right? Just like a VM OS, even it's not a VM, it's the container actually, right? So after 20 seconds, you can use this one again. You can see this already be quit. So here you can see already exists, right? Because this app only run 20 seconds, then you will crash. So that's why you also this container also be crashed later. Okay, so that's why the first one misunderstanding. Like I say, we should not compare container with VM. We should compare the container as a services. Okay. Then the second misunderstanding is, do we need to log in to container to do some maintain and do some change, right? If for the VM, it should be normal for you. You always need to log in VM. At least you need to do some patch or install some application there, right? It's normal behavior, right? Like VM is another type of the host. VM should compare with the bare metal, right? Let's say you need to log into bare metal machine to do some change. Then for sure you need to log into VM. But for container, it's totally wrong. You should not do that, right? Container, everything should be software defined. Everything should define as a code, just like in here, right? In here, this is a code. is called Dockerfile, right? Container should always be as a code. So code benefit is so code can do some version control, right? You can use a Git, can lower bare and different branch, right? Everything is under version control. So that's the good thing of the code, right? Every time when you try to maintain a container, you always update the code. You should not log into the container itself to do some change, because otherwise you become hard for other people to continue to maintain your container. Actually, by the way, I should not say maintain container. Container should not be maintained. Anytime when you know upgrade or know the old container, just destroy it and rebuild a new one. So that's the difference, right? For VM, you always do some patch, always do some maintain, always do some power on. Sometimes you need to do vMotion, right? Migrate one VM from one host to the other in case of the host die, right? For container, none of them will be true, right? You no need to do vMotion. You always destroy container in the old one and rebuild it, then bring out another new one in the new host. Also, you no need to log into container yourself. You just always update and Dockerfile and build a new one. That's it, right? So everything is software defined. Everything is a code. This is called infrastructure as a code, right? Okay, so we will stop here first in this first video. Thanks for watching.